to chemistry concept videos. So in this video we are going to check how to balance a redox reaction by using oxidation number method. Probably in the next video we will be discussing about how to balance this redox reaction, same redox reaction with respect to half reaction method. So coming to this, here I have written one redox reaction, MnO4 minus at aqueous state and I minus in aqueous state gives MnO2 in solid state and I2 in solid state. So first step, what I have to determine in the oxidation number method is I have to check the stoichiometry of the central atoms. Check the stoichiometry of central atom. So here I am having Mn, so it is balanced. And here I have I minus and here it is 2I. So I have to stoichiometrically balance by using 2. So the next step, explore the oxidation states or oxidation number of the central atom. Here the oxidation number of KMnO4, if you calculate, you will get plus 7. And here as MnO2, the oxidation state of Mn will be plus 4. I minus, the oxidation state is minus 1. And here I2, the oxidation state is 0. So since we are having 2I minus, I will multiply this with 2. So this is minus 2. So now I can check the reduction process. There is a decrease in oxidation number. So the decrease change is 3. And here I am having an increase in oxidation number. So change in increase in oxidation number is 2. So now what I have to do? I have to balance both the increase in oxidation number and decrease in oxidation number with respect to its stoichiometries. So I have to multiply this with 2 and multiply this with 3. Now, so this is multiplied by 2. So I will put 2 MnO4 minus and 2 MnO2. The next step, this is multiplied by 3. So I have to multiply this with 3. So already I am having 2. So 2 into 3 it will become 6. And here 3. That's all about the stoichiometry of the central atoms. So now what we have to balance is the number of oxygen present on either sides. So here we are having 2 into 4, it's 8 oxygen. Here 4 oxygen. And in this we are not having any oxygen. So definitely I have to balance by using these two terms. Here I am having 8 oxygen and here I am having 4 oxygen. So what I have to do towards the oxygen deficient side, and this is the oxygen deficient side, I have to add H2O. So the difference in oxygen is 4, so I have to add 4 H2O on this side. So if I am adding 4 H2O and on the either side, to balance this H2O, I have to add equivalent amount of H plus. So 4H2, so I am having 8H plus in my hand, I will add 8H plus. So okay, so definitely we have to add H2O to balance oxygen and not that oxygen in the gaseous state, and definitely we have to add H plus to balance the hydrogen and not the gaseous hydrogen. Okay. Now whether we will check whether this reaction is balanced or not. Here we are having 8 hydrogen and 8 hydrogen, 2 Mn, 2 Mn, oxygen, 8 oxygen, here 4 oxygen, here 4 oxygen, 8 oxygen, and 6 iodine and 6 iodine here also. So now the reaction is completely balanced. So once again I will recap all the steps which is involved in this. So first I have explored the stoichiometric balancing of the central atoms. The next step, I have balanced with respect to increase and decrease in oxidation state. I have explored the oxidation numbers of the elements. So then I balanced by cross multiplying the oxidation states. Then next, the count of oxygen is balanced. Towards the oxygen deficient side, I have added H2O. And next, I have added equivalent amount of H plus on the either side to balance this reaction. Okay. So the final one is, this reaction is balanced or this reaction happens in a basic medium. You have to check whether the reaction is happening in the basic medium or not. So if it is basic medium, H plus should not be there in the final expression or final equation. So I have to add equivalent amount of OH minus on both sides. I have to add equivalent amount of OH minus on both sides. Now this will combine and we'll get 8H2O and 4H2O. I'll cancel out. So now the final equation will become 4H2O plus 2Mn O2 minus, O4 minus plus 6I minus gives 2MnO2 plus 3I2 plus 8OH minus. Okay, the final one, we have to represent the compounds, molecules or ions whichever in its respective physical states. So here H2O will be in liquid state and MnO4 minus will be in aqueous state and I minus will be in aqueous state. All the ions will be in aqueous state. And here this is in solid state and this is in solid state and OH minus will be in aqueous state. So that's all, children. So this is the mode of balancing the redox reaction with respect to oxidation number method. Thank you. We'll meet in the next video.